All right, let's check out how to do the rainbow project. I hope the sound is okay, you can hear me clearly. So the rough draft for the rainbow project is on this sheet on the back. And on the side, you'll see this dispersion example. Now a better example of dispersion would be this in color. And we're seeing high frequency light refracts more when it goes into this glass, or red light refracts less. Larger frequencies, like violet, refract more. So that's the refraction element of this. First, I'd like you to get down the definition of dispersion, and I'll just put it here for you. And there it is. Light that has a higher frequency, or lower wavelength, same thing, refracts more since it slows down more, entering a new medium. Just like we're seeing there, high frequency refracting more. So anytime, pause the video where you need to, like to get that down, for example. Okay, so if you rotate your paper, then you have this in front of you, and this represents just 2 water droplets in the sky, and sunlight from the sun coming in and hits, trillions and trillions, and many more than that, water droplets, but this is just showing a high water droplet in the sky and a low water droplet in the sky. Okay, so what you need is a sharp pencil, a ruler, and here we go. Now we're going to draw that sunlight, that white light, refract into just red and violet. We won't have room for all the colors. And what we do, wherever a ray strikes a surface, wherever a light ray strikes a surface, we draw the normal. That's called the normal. It's perpendicular to the surface. And we make it perpendicular by aiming for the center. Now be quite picky about where you draw that normal. It should be exactly where the where the sunlight, exactly where the sunlight hits the surface. So right at that dot, I was just a hair off. It may have been okay. All right, once you have the normal drawn there, then we talked about how a car slowing down or speeding up will bend sometimes, will change direction. So this is water where the light goes slower. And we talked about like how a car coming into the, let's see, this tire's on the slower surface like the sand, and this tire is still going fast. So this tire is still grooving fast, but this is a slowed down tire. Then, just like someone walking and that hand getting slowed down, they're going to rotate down like that. And that's exactly how we're going to refract the light. Specifically, we're going to aim right there, right on the far right point, to the right of the center. That'll make the project work out and the rays join up like we want them to. You'll see. So carefully from right where the sunlight takes off, we don't want to move it and then draw the ray. Right from where it takes off, we aim directly at the back of the water droplet. All right, this, by the way, will be the most refracted ray. This will be violet, and we'll show that pretty soon. All right, then, again, we have a surface being struck by a ray of light, so you draw the normal there too. And now it's reflection. So as long as it reflects off at the same angle, so I'll try it and then see if it looks like it's the same angle. It's the law of reflection. The angle of incidence has to equal the angle of reflection. So you could look at the angles themselves. This angle's a little bigger. So I'm going to tilt this ray a little up. Or you could look at this as a Pac-Man, and this Pac-Man half is bigger than this Pac-Man half. So I'll aim instead maybe right there, and that will make the Pac-Man halves equal. Or those reflection angles in there equal. All right, and this takes patience. Being precise is part of the project. Nature is this precise. That's where all the beauty comes from. All right, so looking at the Pac-Man overall, that's about the same size as that. The angles are about the same. Yeah, that works. Okay, then we have another surface where the ray of light is hitting it, so we draw another normal. Aimed at the center, always aimed at the center to make sure the normal is perpendicular to the surface. I'll repeat a lot of things, such as aim the normal at the center to make sure it's perpendicular to the surface. All right, the car coming out of that raindrop, let's see, it's like this. The light's going out into air where it speeds up. So this wheel is going fast, or that like part of the light, if you will, is going fast. This part of the light is still slowed. So just like a person walking with their hands out, if this hand gets slowed, they are going to get curved that way. Instead of down like that, they would get refracted. That's what the light is doing. Refracted up pretty much to the left would work. If you go directly to the left, you'll see that your whole picture looks the same on top and bottom, and it should. If we aim right at the center. If we aim right at the center. So this violet light refracts straight from where it hit the surface. So see that? I didn't jump over and then draw the ray. It's just a continuous ray, refracted ray. Okay, so this will be violet. We're going to show red next. And I would label it right where I'm labeling it to make room for the red. And then here's violet light coming out of there. All right, so that's the violet ray of light. And in your project, you can make sunlight black, but this will be a violet ray, actually in the color violet. Okay, time for red. Red comes from the sunlight also, from right there. But it doesn't refract as much. So as long as it doesn't go straight, because it refracts, as long as it refracts less than violet, you're good. Something like that. So it didn't go straight through, definitely refracted, but it refracted less than violet. Okay, so here we go again. We have the ray of light hitting the surface, so we draw the normal. Like that. Okay, right where it hit the surface, that's where we draw it, aimed at the center, so it's perpendicular to the surface. So here's another Pac-Man problem. So we have this size, we want down here also, or these angles should be the same thing. So I'll show one that may or may not work. Let's see what happens. Okay, let's take a look at that ray. And looking here, the angles look the same. Looking at like the Pac-Man parts, the half up here, looks the same as this little half down here. Yeah, it's close enough where I would allow it. So that's where red goes. And one last part. If we draw the normal, again, right where the ray hit the surface is always pointing the ruler at the center. It'll refract just like the violet did, kind of upwards to the left. But choose an angle. Don't have to be too picky. I'm going to aim for the S in sunlight. Why not? Like that. So red is refracting down like that. That's going to hit our eyes on the ground. So that's something we'll get back to. So if you need to, go back and see the process again. See that whole process that we took there. And the bottom one should look exactly the same, because sunlight is coming in at the same angle. These are parallel rays of sunlight. So every droplet would have that kind of refraction and reflection going on. So in the end, you'll have two of them. After you have the top and the bottom, they're exactly the same. All right, if we zoom out, check it out. So there, you'll see an eyeball right there. So notice, us on the ground, we see red coming from the higher water droplets. Violet goes over our heads, we don't see that. From the lower droplets, we see violet. Red goes down towards our feet, or just doesn't hit us at all. So we see red coming from the higher droplets. That's why red is higher in the rainbow. We see violet from lower droplets. That's why violet is lower in the rainbow. So that's part of what you need to get checked off. Now if you read this paragraph, it says, this is a rough draft, even though it should be pretty exact over there. Only after your picture, that, and paragraph we'll talk about next, only after those are checked off, then start the project, which is pretty much replicating your picture but bigger, in color, and then a nice neat paragraph written on it too. So let's talk about how to do that paragraph. One moment, I'm going to get my notes, I'll be right back. Okay, so what I'm going to show here is a list of just main ideas that you really want to touch upon. Your Rainbow Project summary tips are right here. Okay, so I'd like the summary to be in paragraph form. These are just main ideas, main pointers. Let me fix this a little bit so you can see that better. Okay, and still show the picture, why not? Yeah, so as long as you hit those main points on how we see rainbows, from red on top to violet on bottom. And I'll give you several examples for how you could hit these main points. You could pause the video and please put it in your own words, although I'll be repeating a possible paragraph lots of times. Maybe sentence by sentence. That sounds good. Okay, your first sentence must address how it all starts. That sunlight strikes rain droplets in the sky, and dispersion takes place, or the light is dispersed, or it disperses. However you put it, just mention how it all starts. Sunlight is striking rain droplets in the sky. Make sure you don't say raindrops. Raindrops fall. Rain droplets are about 100 times as small and are suspended in the sky. Okay, after you mention that, this is the tough part. Mention what dispersion is basically and why. So state what color refracts more. So remember, that's the higher frequency violet light. And it refracts more because it slows down more.